Cool physics, folks. So we are going to show you in this video how to be able to obtain the value of G out of the data of times that you would have collected. In the end, your spreadsheet should look pretty much like this. But how did we get to here? Now, I am not going to be typing all of this stuff that I'm highlighting right now, but you will though. So I'm just going to copy these before I would close this window or this tab. And then I'm going to pretend, okay, now, so you opened your Google Drive or your Google Docs thing. You click on Create, and then you scroll down to Spreadsheet. And at this point, now in your case, you're supposed to be starting to type here in A1. And in my case, I'm just going to paste from before, so I wouldn't have to do that and save time video-wise. Okay. Always, if you wanted to make the column a little bit smaller or bigger, you use this here, right there. So I'm going to double-click on that. It made it smaller. Notice here how the 0.6 and the 0.6 also do not seem to have two sig figs. So we're going to have to fix that problem by highlighting everything, and we go here and say give us a 2 decimals option. So now everything has 2 sig figs. At this point, we're going to try to determine the value of G from these data values, and we're going to refer to the formula that we gave you in the lab sheet. So G, which is equal to, when you do the math, you'll be able to find that it is equal to 2D divided by T to the power 2. Now from this, we would be able to conclude then that we need to take 2 times, so in this case it's going to be equal to 2 times 2, which stands for the amount of meters, divided by, and in this case the t squared, they are going to be extracted from this column right here. I'll show you in a minute how you would be able to do that. The unit that we are going to be working with in this case is meter per square second, and that's why we put the unit there. Notice how this is, I widened it. I'm going to double click to make it fit nicely. And at this point in Excel, just as I demonstrated in class, when you put equal, as Excel understands that you are going to be entering a formula. So in this case, I'm going to enter 2 times 2. Of course, if the distance here is other than 2, you would have to enter, for example, 3 meters, 4 meters, whatever the case may be. And then divide by, and you click on the cell of the corresponding time, and you put to the power 2. Hit return, and voila. Now you've got the time, the value of G associated with this time right there. Of course, the value of G being with this many sig figs is kind of ridiculous. We're going to have to stick with, at most 2 sig figs here. So in that case, I am going to go again to here, and I'm going to say, for the time being, we're going to go 1 additional digit just to be, safe, because we still are in middle calculations, and then we'll reduce everything in the end. At this point, we pull this down to tell the spreadsheet to replicate that format. At this point, now we've got the different values of G. Of course, like we said in class, the experimental value is going to be the average value. So I'm going to enter average G. Again, the unit is going to be in meter per square second. And close the parentheses. Hit return. Now what we would like to do is type equal, so the spreadsheet would know that we're entering a formula. Start typing the word average, and as you can see here, it's already there, so I'm going to select it, and then I'm going to select the cells that it's going to average, and then close the parentheses, hit return, and now this is the average value right there. Again, I would like to reduce the number of decimals to just 2, that's plenty. and double click in this to make the column be nice. At this point we're going to do the standard deviation because we would like to get the estimation of the error. So the standard deviation, again, it's measured in meter per square second. It follows the same kind of format because we still are dealing with the value of g. In this case, the gravitational acceleration due to gravity, or the acceleration of gravity as some people like to call it. At this point we'll put equal, just like we did in class, stdev. So it's already ready for me right there. I'm going to select that, and again I'm going to tell it I want the standard deviation of these data values. Close the parentheses, hit return. Once again we should reduce this reasonably enough. And at this point, the next thing is to determine the SDM. And the SDM is, again, measured in meter per square second. And close the parentheses, hit return. And if you recall from our lecture, SDM is equal to the standard deviation, so it would be this number here, divided by the square root, as we explained, the square root SQRT of the number. And the number in this case of measurements is 20 values, because as you can see we started here at 2 and we're on to 21, so that means we collected 20 data values as we were instructed in our lab. At this point, hit return. Once more, we're gonna make this number look a little bit more reasonable than the 50,000 digits there. Double click to tidy up the column. Now this is going to give us what we call the standard error. So you do Option J on, before you do that, you would have to hit Option J. That would give you the delta symbol, and then G, again measured in meter per square second. And at this point, hit return. As we explained in class, this is supposed to be equal to twice the SDM. So twice SDM. So I'm going to widen this a little bit, then double click to tidy it up. And at this point, go back here, equal, and we do 2 times, and the SDM is right there. Hit return. And at this point, we're going to take this number again, and we're going to try 2. Very good. At this point, my friends, okay, we've got our G, average G, that is the experimental value. We've got our, our delta G. So the final result should be reported as, of this experiment, final result should be reported as G. You do Option Shift and the plus, and the equal key, and that would give you plus or minus. And then delta, which is again Option J, and then G equals, and then we put the actual values, except for this. For now, there's no need really to go for 2 digits after the decimal point, because the value of G, we're not going to be able to know it, for more than just 2 sig figs. But so in this case, we're going to be reporting at this point 10. Okay. Actually, I made a mistake here. Actually, the times were given to us actually in 3 sig figs. I missed to put that as actually there are 3 digits there, so it's actually 0.2. Okay, and then Shift Option, press together, plus or minus 0.8. And at this point, I'm gonna close the parentheses, put meter per square second, and I would like to close the parentheses here and hit return. Again, widen the row here, just like that, and then double click. Okay, now I'm going to select this cell and I'm going to hit boldface because it's a very important final result, and red to heighten the fact that that's the ultimate result that we are getting. Now in here, I am going to put the two values, Gmin and Gmax. Gmin, you obtain it by doing the subtraction over here. So equals, and then 10.2 meters per square second minus 0.8 meters per square second, and that should give us equal 9.4 meters per square second. So this is, sorry, again, we'll widen this. There we go. Double click to make it tidy. And then I am going to not waste my time. I'm going to select this, do copy, and go down here and paste. And I just go down here and change this to Gmax to save myself time. I don't have to do all of this kind of silly business. And then plus, and then at this point, when we do 10.2 plus 0.8, that would give us 11.0. 11. And if we stick with the idea of having 11.0 right there, and hit return. By the way, if we go right there, we should be able to have 3 sig figs there too. And at this point, what this means is that now we're making the following claim. We hope that any person who is doing this same experiment, like us, 95% of the time, their mean value is going to fall between these two values right here. In addition to that, we hope that the real value of G would be somewhere in between here. And if that's the case, that means there are no systematic errors in our experiment. If, on the other hand, the 9.8 meters per square second is not within this, then we have to claim that there got to be some systematic errors. As you will find in the literature, G, the real value, is actually 9.80 meters per second squared on average in our area here. And at this point, we are supposed to see here, as you can see, this falls right within here. So in this case, for this data set, people should not claim any systematic errors pretty much of any kind. Of course, to determine the percent error, you would have to do the real value, 9.80, minus 10.2 absolute value, then divided by 9.80, multiplied by the 100. I think you can handle that yourself. At this point, it would be wise to save your spreadsheet. You could call it, maybe your name. In my case, I'm going to call it Miscelanage Cool Lab02 spreadsheet. Okay, hit return. And with this, my friends, you've got a real nice looking spreadsheet of your lab number 2. Thank you.